welcome to today's Rec Research webinar. For those that don't know me, I'm Dan Ferguson, the Executive Officer of Parks and Leisure Australia VicTas region, and I'm hosting today's session. Before we kick things off formally, I do want to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past, present and emerging, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Recognising that we are all online and likely signing in from different areas, I obviously want to extend that out to wherever it is that you are logging on to today. Noting I think we've got a couple of interstate people logging on today as well. So extend that out to wherever it is that you're signing in from. So today's session, as I said, is a rec research session where essentially what we try to do is get the latest research in front of practitioners. So the people at the forefront. So this is an initiative that's a partnership between Rec People and PLA VicTas, and we run these sessions. We try to do them bi-monthly, so relatively regularly. And as I said, it's all about just getting new research in front of practitioners, so those that are there on the coalface, and just really learn and hear from new research. So find out about what's going on out there, who's doing what, and see if you might be able to apply that in your day-to-day work. We provide these completely free for PLA members as part of our offering back to our membership. And again, it's just about making sure that we're spreading the word of the good work that's happening out there from a research perspective. In terms of, I guess, a bit of housekeeping of how today will run, there'll be a very quick intro, which I'm doing right now, and I'll try and get this over and done with as soon as possible for you, so you're not having to listen to me. But we will have a presentation today from our guests, which will go for around 30, 40 minutes, something like that. And then we will have time for a Q&A session at the end. With the Q&A session, I will invite you to take yourself off mute, put your camera on and ask the question directly if you wish to. Alternatively, you can drop your questions into the chat function and we can pick up the questions from there and I can ask the question on your behalf. As we're going through the presentation today as well, if you do think of a question, feel free to drop that question into the chat function just so you don't forget it, and we can come to it at the end as part of the Q&A session and pick it up there. So on to today's session, grass and glass. So growing natural turf from recycled glass sand is what we're looking at today. So we're lucky enough to be joined by the team from SportEng, where they're going to be sharing information about a current research trial that's underway, where they're essentially testing whether recycled glass sand can be used as a growing medium for natural turf for fields of play. And it is a research trial that they're doing in conjunction with the City of Boroondara, with the hope that it might open up the opportunity to develop natural turf ovals and pitches with a fully recycled product. Fingers crossed, we'll see where that gets to, and I'll let the team explore that further. I do want to note that this was a commendation winner in the 2022 PLA VicTas Awards of Excellence for Best Use of Technology, so last year, so congratulations to the team on that. And today we are lucky to be joined by Amy Dingle and Lucas Skelton from SportEng, who will be going through the research trial today and giving you all the ins and outs and the behind the scenes of where that has got to. So that's it in terms of the formalities from my end. You're not here to hear from me, so I'll hand it over to Amy and Lucas. I'll stop sharing my screen, let you take over, and we can go from there, team.
Excellent, and thanks, Dan, for hosting and providing this opportunity. And good afternoon to everyone on the call. It's a really good opportunity for us to be able to bring together some of the data and thinking around this research project that we've been undertaking here at SportEng. But before we get into the presentation, I would also like to acknowledge the traditional owners of the land. And Amy, if you could keep moving, thank you very much.
Got it.
So as Dan mentioned, we are all meeting in different places across the country today. And so we would like to pay our respects to the elders past and present on all of those lands. Thanks, Amy. So a very quick starting point in terms of SportEng for those of you who may not be aware of who we are and what we do. So we're a specialist consultancy in the field of play space, planning, designing, monitoring and managing projects from inception to completion. The business started in 2014, has grown to a team of 32 people across the country, working out of offices in Melbourne, Sydney, Brisbane and Perth. There's a fair bit of experience across the board with everyone from graduates coming out of the university system all the way through to practitioners and people who have worked in the industry for 30, 40 years in John Nayland, Andrew Morrow, and Jared Hill, one of our directors. Over 800 projects we've worked across the country, from everything from stadiums down to the local fields that many of you who are in the local government or school spaces are responsible for. And as Dan mentioned, we at time to time, our work is recognised with some awards, which is fantastic. Thanks, Amy. We're a bunch of multidiscipline team, so we cover off on civil engineering, civil design, turf grass agronomy, irrigation design, and also asset and project management. And I guess just as an introduction, further introduction to Amy and myself, Amy and myself are both in the turf agronomy space, and we lead and deliver our field of play services. So we've essentially got two sort of arms to our business in terms of field of play design, which is led by our engineering team and design team, and then we complement that team with the field of play services, turf agronomy, irrigation. But in terms of our overall offering, because we have a multidiscipline team with various experience from working in construction to maintenance to local government, etc., we're able to provide a broad range of services which are listed there, one of which is undertaking research and development trials. And at the moment we've got a number of trials underway, the recycled glass being one of them. Thanks, Amy. So I thought we'd start the presentation discussion around the trial with just a comment around the drivers for change. And so why do we see the need to do this? And I guess at the highest level, we see that there is down the line, and even in the current state, there is a level of unsustainability around the way in which our playing fields are managed and maintained and constructed. And therefore, because we are at the coalface of working with many of our clients who are in the education, local government and professional sports space, we are seeing day in, day out the challenges that everyone's facing across the life cycle of a field of play, whether that be at the planning stage or right through to the maintenance phase. And so some of the key drivers, I guess, that have really prompted and driven us to want to look into different alternatives and options for fields of play have been these four factors, which is changing climatic conditions. No matter where you are in Australia, we are definitely seeing changes in climate, and that can be changes in temperature, rainfall, the seasonality of our seasons, so shifting periods in which our seasons occur, and that is contributing to the sustainability and the performance of our fields. Increased hours of use, no doubt, with increased population, increased demand, increased interest in sport, we're definitely seeing across the board an increase in the hours of use required by our fields. The increased participation and also demand for playing fields can be linked to the performance level and the ability for fields to perform or provide for multi-sports, and not only multi-sports in one particular season, but potentially across across a full year, so summer and winter seasons. We're also seeing the prevalence of sports moving their seasons and seasons running for longer periods across the annual calendar, reducing the windows for maintenance, or working out of those typical growing seasons whereby our fields have that time natural fields have that time to recover and be able to sustain a level of quality while also carrying the increased use, but also the level of use as well. And as those expectations for quality fields continue to increase, there are definitely pressures that we're all experiencing on trying to maintain and also improve and upgrade the fields that we have under our management. And one of the things that's most related to this particular aspect is the finite sand supply. So we're really aware that there is a finite sand supply, and that there are many parts of the construction industry and the global economy that require sand to progress their endeavours. And we've definitely seen that here in Victoria recently, with the increase in construction, major construction projects, and the competition for sand as a product within products. And so it's definitely a risk. All of these things we see as contributing to the result of having sustainable and or unsustainable playing fields, whichever way you look at it. And we think that this is part of looking at all the different components of a field of play, in particular the root zone, is really important to understand, well, what are our options? Where do we need to move? Thanks, Amy.
Sorry, I think I was on mute for a second. As Lucas was just saying, there are a lot of different factors which are contributing to our current unsustainable construction of sports fields. So I'm just going to break those down further into three that SportEng have identified as being probably the major three at the moment. The first one being the decreased availability of sand. So as we've all experienced, there's been a construction boom over the last few years in New South Wales and Victoria, which has created increased competition for resources. So a lot of our sports field sands, our parameters for those sands are a lot stricter than those that are for asphalt or concrete mixes. So a lot of the time it's easier for quarries to sell off that sand straight to the asphalt or concrete company instead of trying to either blend the material or try to wash it to meet our criteria, which is a bit stricter for sports field sands. Obviously, it's a little bit stricter because we are trying to grow something in our sand, whereas asphalt and concrete is just as the form it is. So yeah, easier for the quarries to supply to the asphalt and concrete mix, but as well as that, we've seen a lot of the smaller quarries have been bought out by the large concrete manufacturers, which has reduced our supply options as well. And on top of that, in 2021, Australia was the second largest sand exporter globally. Coming in first was the USA. So a lot of our material here is being transported overseas. So we've got the decreased availability, but on top of that, we've also got increased demand for the sand-based sports fields. So with a lot of the work that we do at SportEng, we've seen that a lot of our sports fields are around 20 to 25 years old at the community level, and often these were built without any subsoil drainage and with poorly draining native soils. On top of this, the maintenance staff shortage across the industry makes it really hard for these teams to maintain these older designed sports fields, which often require a lot more reactive maintenance. And sometimes they don't have the funding to keep these at the level that they should be. And then to further this problem, we've got a growing population, we've got increased participation, we've seen a lot more of the women's sports clubs grow over the last few years, and the demand for the playing field usage has been incredible, but has gone beyond what these fields can currently cope with. And as Lucas mentioned as well, they're having year-round usage. So a lot of the time now we're not really seeing that distinct break between summer and winter sports seasons. Often these fields are only getting a week or so where they're not being used. And over this time, it's still being used casually by the community at that community level. And then the current methods are unsustainable. So as far as from an environmental lens, quarrying sand directly from the earth is unsustainable. Sand needs thousands of years to form, and we're using it much faster than it can be produced. So the United Nations now officially refers to sand as a finite resource because its loss and degradation is not recoverable within a human lifespan. So the mining of sand directly from the earth can result in soil erosion. So this is when a lot of the time when the vegetation, the trees, the grass is stripped back, water or wind can remove the soil, which can affect the fertility of the soil, but can also impact water quality in nearby areas. deforestation, which I'm sure a lot of us are familiar with, but a lot of the carbon stored by trees is released back into the atmosphere during this, and then this is contributing to the changing climate. I know a lot of councils and organisations are trying to reduce their carbon footprint through carbon offsets. So therefore, it's important to acknowledge that the indirect impact of some of the choices made when going through sports field construction can impact those carbon offsets. And yeah, just a disruption to our natural ecosystem overall. Back to you, Lucas.
Thanks, Amy. So I guess in terms of when we look at all of the various contributing factors to the challenges and the problems that we see, both now and into the future, we also are keenly interested in looking at then what are the solutions and what are our options towards being able to navigate through this, because we understand that the social benefits of recreation at all levels is critically important to our communities, and so therefore we at SportEng and working with our partners and clients want to be able to explore and investigate a range of different solutions. And typically in most projects, if not all projects, when we're working from the very beginning, we were trying to identify a number of strategies and approaches to be able to solve the problem of both meeting the recreational community need for sporting facilities, but also taking into account and understanding the sustainability of a playing field, and I guess the long-term viability of the asset itself. So it's something that we're really mindful of when we're working through that early design stage, is what are the things that we can incorporate and build into the field of play design, which may be able to create sustainability across all different lenses throughout the life cycle of that field. And this diagram aims to demonstrate that integrated approach. So by considering a number of different options and looking into those, investigating the ability to partner with local or regional groups who may have fields to be able to meet the need, or coexist on those particular fields. And we are starting to see opportunities whereby schools and council, or schools and clubs and associations are working together to identify and work through options to be able to unlock availability, but also looking at the level and quality of sport that may be needed as well. I know from a local government perspective, many of our and schools, they are considering doing a lot of work in the policy and strategy space to be able to understand the levels of participation and the type of sport and the type of the level of sports that are being offered. So again, regionally, does every council or every school need to have elite level surfaces for all sports? The answer is typically no, but a spread of those sports and levels of playing surface and types of playing surface in a regional area can definitely provide the level of service and provision that is needed for that community. So again, looking at the size of fields, looking at the componentry, so looking at whether fields have surface levels, surface fall, being able to move water away, drainage, subsurface drainage, irrigation, turf type, even the type of turf itself. So whether it's natural, hybrid, or artificial, are all options and things that we're considering on every project to be able to meet the demand for now and into the future. But linking back to our research project here is that we're also really keen to understand what are the alternate material. So where can we substitute a particular material for another material that may be a lot more available and it'll have a lot more sustainability into the future. And this is where we now look into and investigating the viability of recycled glass. Thanks, Amy.
Yeah, so when SportEng came up, we came up with that problem. Oh, sorry, didn't come up with that problem. We're faced with that problem. We thought that while sand is becoming much scarcer, there is a growing amount of glass wastage which is going into landfill each and every day, just generated through human activity. So using this recycled glass creates a circular economy. So the recycled glass isn't being used once and ending up in landfill. It's instead being processed and being reused again. With this process, there's no need for quarrying from the earth. So a lot of those environmental impacts are immediately erased. It will reduce the waste going into landfill. And then lastly, the ability to make a consistent product that can be ordered ahead of time for projects. So from our project management lens at SportEng, we noticed that a lot of the time, sourcing sand for these jobs that meets the sports field criteria has become a lot more challenging and has been a more time-consuming process. Obviously, being a natural product, it can be inconsistent a lot of the time, and the quarries might have to blend it to try and reach our criteria, or they just might not have any available at the time. So we're finding either the projects are then being delayed, or a inferior product is having to be put into the ground, and therefore the end of the equality of the playing field is not up to the standard that the client originally wanted. So that's why the ability to generate a man-made product can also be very beneficial in the construction space. So a little bit about this product. It's made from problem waste glass fines. So these are ones that cannot be recycled back into glass bottles or jars. Particles are rounded and safe to handle. They contain a silica level lower than natural sand, and the product is washed during the manufacturing process as well. So just a bit of an overview of, I'm obviously not aware of everyone's backgrounds, but just giving it some very basic, this is our sports field profile design that we have. So this top layer here, which would usually be our root zone sand or quarried sand, is where we're proposing to install the recycled glass sand. Then we've got our drainage gravel layer and some subsoil drainage underneath. The reason this layer, the recycled glass sand or the root zone layer, is so important is because we've got to support that healthy turf growth on top. We've got to create a safe surface for sports field users, one that is stable underfoot and a surface that's not too hard, especially for some of those more high impact sports. As well as that, we need a surface that's fit for purpose, allows for fair gameplay in sports. So you're not going to kick the ball and it's going to bounce off in another direction because the surface is uneven. And probably our biggest buzzword in SportEng is making sure the drainage is good. We focus a lot on the drainage because we don't want that water to be sitting in the top of the profile where the turf roots are, because that can cause stress to the turf. So we want that draining through the profile into the subsoil drains and being carried away. So just a little bit of Soils 101, just because that's a lot of my background. Very basic diagram of what we've got going on within the soil, or in this case, the recycled glass, which is our solids there. So in your profile, you've got the air. The air is important for cellular respiration to occur. So the roots of the turf need to absorb air because they use that to break down sugars and release energy and encourage turf growth. The air is important as well for microbial activity, which improves the soil structure and breaks down organic matter. They allow water to drain through, so once again, drainage, to prevent any waterlogging and preventing those boggy surfaces that I'm sure we've all experienced before. And as well as that, they allow the turf roots to grow through these air-filled spaces and, really anchor the plant in and create a very healthy surface. We've got the water component as well. As plants absorb water, they can also absorb nutrient that's carried in the water, which is where a lot of our fertilizers go into. We need it for photosynthesis to occur. It also helps with temperature regulation, so it'll help keep the temperature at a constant rather than have huge fluctuations, because those extreme changes can cause stress to the plants. And then we've got our solids, so this is where our recycled glass would be. It's a structural anchor for that turf to grow. It can store nutrients, store water, and it can help with disease suppression as well. So that's just a little bit of the basics of the three areas that we're looking into today. So this is those three things probably broken down into a more scientific way of looking at it. So when we were setting out to install our recycled glass plot, we sent off to the lab, the product, to get it tested. So we did the recycled glass, we did our typical root zone sand, And we did a 50-50 blend of those products to see if they work well together. So just to break down this one a little bit more, our total porosity here is that's looking at the total amount of pore space into the soil. So that could be pore space that's holding water or holding air, but just the total amount overall. And as you can see, our recycled glass product does fit within our typical root zone sand specification. Then we've got our aeration porosity, so that's measuring the amount of air, so the air that we saw on the previous slide within that space. Once again, that was compliant with our typical root zone sand specification. And lastly, we have our capillary porosity or moisture retention. So that's telling us how much of that moisture or water is retained in the profile. So as we saw before, that's how much is held there, which is important to support our turf growth. We found our recycled glass was on the lower end of the root zone sand specification, just because I think those particles are slightly larger and they don't pack together as tightly. So there was a little bit less tension to hold the water in there. Our 50-50 product though did fall within the specification. And also we have our hydraulic conductivity. So once again, back to the drainage. So this is really good because this indicates that the profile is going to drain properly and we're not going to get a saturated boggy field in the winter months. So that was draining at 460 millimeters an hour, which is really good. So our stage 1 trial plot we set up at Freeway Golf Course working with City of Boroondara. It was a nursery plot set up in their turf nursery, which consisted of 3 sites. So 1 row of sand, 1 row of the recycled glass, and 1 row of the 50-50 blend. And we monitored it for 6 months, looking at things like root growth, turf health, soil moisture, surface hardness, and surface traction. So these were some of our images here when we measured the root growth. So as you can see, our recycled glass sand is the one in the middle there. Root growth was down to about 320 at that point, which is really good. The 50-50 glass was similar, and surprisingly, the regular root zone sand was a little bit shallower. So that was only at about 280 for that one. So there we've got our trial plot there. So you can see the recycled glass is the nice white product on the right. Then we've got the 50-50 in the middle and the sand on the left. So some of the results and data we got from our stage 1 trial was 277 millimeter average maximum root depth for the recycled glass. Obviously, sometimes we went out there, it was higher, sometimes it was a little bit lower. So that was our average across the 6 months. There was no significant difference between soil moisture, surface traction, and NDVI across all plots. So NDVI is turf health. And that was really good because that's showing us that our recycled glass product is performing just as well as the regular sand is. So the maximum root depth of the 50-50 blend did perform better than the other 2 plots. And the surface water infiltration rate was also greatest for the 50-50 blend. So that's really important once again to drain our water through the surface into the profile and down out through the drainage. So the 50-50 plot was marginally better than the other 2 plots. So that's why moving on to our recent stage 2, this was our product that we were testing in stage 2. So we worked with City of Boroondara once again to install stage 2 in February at H.A. Smith Reserve. We chose this field due to the combination of winter and summer sports usage which it had. It also had a lot of passive community usage, a lot of dog walkers, a lot of people going out there to kick the footy. And it was also had a community level of maintenance, and it also had, community level of usage hours as well. So we thought it would be a good representation of a lot of the sports fields that we will see when we're working. So we put the 50-50 blend in 2 test locations, which are highlighted on the map here. So we've got one located near the building. So this one was designed to test how the product performed under a high usage condition. So we realized there'd be a lot of traffic across that area being adjacent to the building, and there was also a pathway leading to the stairs there. So there was going to be a lot of foot traffic, a lot of usage on and off the field. So that was our high usage plot. And then we've got our low usage plot further to the south in the quarter of the goals there, which would be a lot less traffic over that area. We just wanted a point of comparison so we could see how it performs under those 2 conditions. In addition to that, we were also testing random locations throughout the rest of the field on the regular sand there, just to provide an experimental control. So these are the photos of us setting up the trial. So we essentially dug out the existing sand and blended it with our recycled glass sand, which you can see in the image on the right there, which is that white colored sand. So we blended it all together, and then we reinstalled it and re-turfed it using the existing turf as well. So the three things that we were really focusing on measuring and monitoring was the surface hardness. So that's a measure of the surface playability, the soil compaction and strength. And we've got our preferred ranges for each of these here as a guide. The soil moisture content within the soil, and then our traction. So our traction device looks a bit like a football boot, and it kind of measures the amount of grip and the friction between that device and turf surface, which is really important for playability of the surface. So this is our first lot of results. So this was for our surface hardness. You can see our preferred range has been highlighted in the orange there. So green is our control plot or the existing field, orange was our low usage, and blue was our high usage sand plots. So initially a lot of our 2 recycled glass plots started a lot lower because they weren't compacted when we originally put them in. So we obviously took all that soil out, churned it through together and then put it in, but we didn't undertake any compaction after that. So compaction is something that will occur over a period of time. You know, the more usage, the more compacted your soils will be. So that's why we saw quite a rapid increase in the surface hardness initially. We did find though by 6 months in that all of our surface hardness was at a similar point. So we're really interested to see how it goes over the next 6 months as well. So they're all currently at a very similar range. Next, we looked at the soil moisture. So we did notice that our low usage plot, you can probably see it's a bit of an outlier here, was a lot lower than the other two. We have a feeling that this plot is situated near a subsurface drainage line. We haven't confirmed that yet, but we think that's what might be going on there. Otherwise, you can note that our high usage plot and the control plot were performing almost identically across the year. The high usage plot was draining out a little bit faster than the control plot, which is just because that recycled glass did have that lower moisture retention when we were looking at it at the test results from the lab in the other slide. And then lastly, we were looking at the surface traction. So none of our results were meeting our preferred range for the surface traction. There are a number of reasons why this might be, but there was very high usage across this field, which had worn away a lot of the turf surface. As well as that, a lot of the time to meet our preferred range of traction, we measure that based on a couch grass variety, whereas a lot of the surface here was Poa annua or winter grass, which is a bit of a shallow-rooted invasive species that has poor traction and a very shallow root system. So a lot of the time that is not ideal for a sports field. So that is a cool season winter grass. So hopefully that will start to die out. And as our warm season grass returns, we can continue to test this and hopefully get some better test results for that one. So the conclusions of our stage 2 were that the 50-50 blend is performing very similar to the control, which is fantastic because we're not trying to prove that this product is better than the existing sand, but we want to say that it is an equivalent that can serve the same function for us. So it has shown good results in both the high usage and low usage plots. It's provided a well-draining sports field profile. So throughout the entire winter season, we were out there every month, and not once was the field saturated, and not once was it a boggy surface. So it was draining really well with the recycled glass. It can support healthy turf growth. And lastly, it has a strong potential for acting as an alternative growing medium for turf. I might have raced through these ones a bit too quickly, have I?
No, you've done well there, Amy. A lot of a really good summary of the research trial to date, and hopefully there'll be some good questions and discussion come out of this. So to round out, I guess our presentation part before we move into that Q&A phase. Some next steps for us, and I guess as Amy alluded to, we want to see this trial, in-field trial, move through another 12 months. So we want to see the trial perform under spring, summer conditions, and then another winter, whereby we can continue to build and understand the performance throughout those different climatic conditions, but also through the different seasons, different sports, different maintenance inputs, and see the different reactions and how it performs over that longer period. So we're going to continue to track and monitor that these trial sites. We continue to work with industry partners around the viability of the processing and supplying of the actual glass product itself. So we're continuing to discuss and investigate how this product, how glass can be refined and can be produced at a scale that is going to be able to support the sports industry's needs, and also looking at other options in terms of the glass product as well, i.e. can it be used as a substitute for drainage aggregate, so refining it back to a 5 or 7 mil product as well. We will continue to look at opportunities to expand our research, so both for a full recycled glass trial plot, and also to take this project into another climatic region or state, whereby we will be able to test its viability with different turf species, different sports, different climatic conditions, and usage conditions, to again really strengthen and bolster our data around its viability for as a sustainable alternative for sports field profiles into the future. So Dan, that pretty much wraps up our presentation components. So happy to throw to you and open up for some questions and discussion amongst the group.
Fantastic. Thank you very much for that presentation. I will open up the floor to anybody that does have any questions. Feel free to raise your hand and I can throw to you to ask you questions, or feel free to drop them into the chat function and we can pick them up. So I'll put that call out now for anybody that wants to put their hand up and ask any questions. But I might just kick off with a quick question to get the ball rolling. But it all sounds very promising in terms of the potential for this and the outcomes of the trial. I'm just very interested to know what holds it back from widespread application, I guess. What are the kind of key roadblocks, I guess, for the industry to consider more broadly?
Did you want to cover that one, Lucas? I think it was very, I was going to say it was very similar to Lucas's last point there about ensuring that our manufacturer, or that there is enough of that product, or they can supply enough at once to support the demand that we currently have. And I guess at the moment there is concern around the cost. If there isn't much uptake of it, it could be quite an expensive process. You know, the more people that are getting involved, the more people who are willing to use it, the more affordable it will become.
Yeah, I think summarising that, it's commercial viability for all the different components through the life cycle. So that's something that we're sort of unpacking with looking at the life cycle, and then working with the partners and stakeholders across that life cycle to really understand how we can make it and what needs to happen for it to be commercially viable across that life cycle and ecosystem, to be able to roll this out on a larger scale. But no doubt it will take some brave, bold people and businesses, you know, to be able to make this move. And you know, from our discussions so far, we believe that there will be those people and companies out there that are able to adapt and pivot to make this move.
Yeah, and on that note as well, you know, give a shout out to Boroondara for being bold to get involved in the trial as well and open up their
absolutely,
you know, public playing field for the trial to even attempt. I might throw to Ash, who I think has got your hand up there for a question. Feel free to unmute yourself. Feel free to put your camera on if you feel like it as well, but ask away.
Hey, Lucas and Amy, thank you for the presentation. I'm keen to understand if you will keep this technology proprietary, will it be licensed out for other businesses to use, I guess? And were there any challenges expressed from council about using the technology?
Thanks, Ash. So the first part of the question is that we don't intend to, I guess, commercialize this product. It's more about creating or verifying for our design purposes and understanding how materials can be used, and then I guess working with partners and people within the industry, especially within the recycling industry, to be able to provide a viable option to repurpose material. That's our main aim and objective here, is to continue to understand what can be used to design and prepare a field of play to be sustainable into the future, which is a core value of what we do here at Sport Engine. We understand that most of, if not all of our clients, being local government, education, professional sport, have similar values and similar objectives as well. And the second part to your question was around concerns from council. So we definitely undertook a risk assessment and workshop the risks and also opportunities at the same time. And I think the result of that was taking the trial into a staged process. So undertaking it in a nursery environment, which definitely minimises the risk of reputational failure or damage if you were to take it straight out into an active field and then it to fail. You would have an issue there, which would have costs associated with it and reputational risk for council as well. However, doing it in a nursery situation at a golf club meant that we didn't have that risk associated with it, and we were able to, I guess, set the trial up so that we could do it in a safe, de-risked environment, but then I guess understanding what our objective was to be able to move into a live situation, that really informed the design of the trial and stage one, because our intention was always, and council's intention was always, to be able to take it to a live site, do it on a small scale, and then be able to continue to build the business case, I guess, for it. And hopefully that will lead to another trial or another stage whereby we can continue to increase the scope of it, because we're proving that it's viable and that it won't have a detrimental impact on the playing field.
Thank you.
No worries.
And I assume that that risk management kind of process with council as well was part of the decision making of the 50/50 product trial, rather than necessarily the full recycled trial as that stage 2 component of things going live. Awesome. I might throw to Scott. Scott, feel free to unmute yourself if you want to. Otherwise, I can ask the question on your behalf. No, I might jump in then. So Scott just wanted to ask the price difference between this product and other materials used for sports grounds. So if you've got anything that you can provide in there in terms of costings or percentage differences, things like that, and whether the material can be used as a top dressing material as well.
I'm happy to answer the top dressing part. I don't have information on the price personally, but it can definitely be used as a top dressing material. We did state in the slides that it is a washed material, and it is really well draining. So we've done particle size distributions on the product as well, and yep, definitely can be used for top dressing. Sorry.
Yeah, and in terms of the price differences, I guess we've done it on such a small scale that we don't have any, I guess, pricing information that was relative to the larger scale at the moment. And we've basically done it on a very, very, very small scale. So unfortunately, Scott, at the moment we don't have a price that would give you a comparison to the current day products or alternatives. But that's definitely a great something that we are working with our industry partners to better understand as they get their heads around what it looks like to do it at a larger scale as well. And that's been the challenge for some of the recyclers in that how do they do it at what quality level, because again, for other purposes where they're recycling glass, they don't have as stringent quality requirements or specific requirements, and they're a lot more advanced in the maturity of that processing. There's an established supply for it, whereas here where it's a very, very limited, where there's probably only this trial and maybe a couple of others. I'm aware of some use of recycled glass in New Zealand as well, but it's done on such a small scale at this point.
Awesome, thank you. There's a thumbs up there from Scott, so thank you for that. Any other questions from the floor, from those that are on the line? Now's your chance to throw your hand up, take yourself off mute if you want. I think you've wowed everybody with your presentations, Dan.
I mean, I probably had a question for the group, Dan, around in terms of, I guess, understanding their current challenges, and is our view of the challenges and the drivers for change, does that resonate with the group, and is there anything else that we should be considering? Are there any other trial aspects or aspects that we should trial with this? Does anyone have any suggestions or ideas to I guess improve the work that we're doing? Because we're open to suggestion, and we want to ensure that our work is going to provide valuable input for the land managers around town to be able to make these decisions moving forward.
There's an open question there if anybody does want to comment on that that's on the line.
Hey, Lucas, it's Ash again. I think I do think you got those drivers, those change right. I'm pretty new into this area, but seeing working with our parks departments on, especially over winter when the grounds are kind of unusable or closed, and we need to move a sports team to somewhere else, and then also being able to open up the times or how the amount of times that we can allocate a sports field to teams, and to be able to grow, especially in the women's and girls space. Just recently, we've been talking about in the open spaces strategy about flood mitigation and how those the grounds act as part of flood mitigation. So that's something that's, I guess, on my mind too.
Yeah, it's a really important aspect, and I think we definitely see a lot of sporting facilities, which do have that dual purpose, and not only just the recreational, social, community, general passive use, but also from a stormwater management perspective, and they are typically the sites that have been allocated to local level community sport. However, as we all know, they're really that cohort of participants is growing, and the demand for sports, all codes, the traditional codes, are now being added to with many other sports as well, which is seeing those areas which probably have been designed for other purposes, stormwater and flood management, are now being asked to do a lot with not all of the infrastructure there to support that. So definitely a challenge we see in our work across the board as well.
Yeah, absolutely. Thanks,
Ash.
Fantastic. Yeah. Any other questions from the floor? No. It looks like silence might be the end of it there, Amy and Lucas. Is there any final comments or anything like that you'd like to make at all from your end? No.
Amy,
no,
giving you more silence.
Yeah, no, perfect.
I appreciate
everything's been answered.
Yeah, no, I appreciate everyone's interest, and thank you to everyone who's tuned in today. Because without any interest, we don't get to do this research. So it's fantastic to have some support for it.
I think sorry, go ahead.
And just to obviously the initiative from PLA to be able to host and provide these opportunities across all of the various areas of recreation and leather planning, and is great. So look forward to the next sessions that are coming up.
Yeah, fantastic. Thank you for that. And look, as I said, this is something that we try and run these rec research sessions relatively regularly. We do have one, I'll do a little guerrilla marketing here. We do have one on the 1st of November lined up with Monash University on informal sport. So for those that are interested, please jump along and register for that one. But it is great to have, while we have focused on university partners and research coming out, it's great to have, I guess, the practical side of the research happening as well, and being able to spotlight that where there are these kind of trials happening. It's one of the things that I love to highlight, and I think it's a big kudos both to SportEng, City of Boroondara as well, for jumping in and kind of having the courage to give something new a trial. It's the hardest thing to ever do, is try something new, particularly in the council world. I think we all know that. so a big kudos for that, and that's why we wanted to highlight what's going on out there. So I think it probably goes without saying, you guys are open to being contacted by anyone that's got interest in the trial or potentially getting involved or anything like that. Or if anyone has any feedback on other things to think about, as Lucas kind of put the call out there, I'm sure you guys are more than happy to be contacted.
Absolutely.
So big thank you. Yeah, big thank you to the SportEng team for today's session. For everybody that are here, there will be the recording of today's session will be sent out. You should get an email probably towards the end of this week that will have the link to the webinar recording in there, and then you'll be able to obviously contact the SportEng team if there is anything in terms of follow-up questions from there. But that's it in terms of the formalities. 3 minutes to spare. So again, thank you, Lucas and Amy, for your time today. And yeah, thanks everybody for coming along today. Awesome.
Thanks, Dan.
No worries. Thanks, Dan. Thanks, guys.